damage that chuck, but we can get enough mass into it where it'll pop and break that taper free. We are living good here because it just came off, so I'm going to just slide this off and set it in the table there. All right, so that's why we have the board here. Really easy to remove and change chucks. So I'm gonna scoot this over just a little bit and take this one down. Set it on the floor for a second, and we're gonna grab our 4-jaw. And the 4-jaw is an independent chuck, which you will see you will not like. Put that one back in there. All right, I'm gonna flip this over just so we can look at this for a second. All right, so mounting this, the way this works is that these pins are gonna go inside of those holes right there, and then it has this little cutout right there. That's where the cam comes in. When you screw this down, it'll actually grab that cutout and draw it in, and that's what locks the chuck in. So the big thing to know before you ever put a chuck on a machine is you wanna clean everything off here really nicely. You don't wanna have any chips in here. You can probably see little nicks and dings already in this spindle. So that is something that just happens over time because somebody didn't clean it perfect. So we want to make sure this is all clean. You can go with air and blow things out. I like to use my hand because I can feel the chips, and I just kind of smoothly go around there and feel for any particulates that are sticking out. Same thing here. Now look at this. There's a perfect example right there of a chip that was left in here, and then it got compressed up against the spindle face. And now it's actually, there just came off my finger. It's stuck to that surface. So if you do that, what you're doing is damaging, and there's another one over there, you're damaging that surface, and that's your mounting plate, and you're gonna lose accuracy. Also, if you look inside of here, you can see a few chips down in here where we don't want them. Just clean all that out. That's where I like to use my finger again. They stick right to it and they come right out. If we had some chips in here, if I could slide my hand across here and I could feel an area that was really raised, I may even go with like an oil stone and go and stone this down a little bit. An oil stone is like a very fine file basically, and it'll take these high points off of there. So when the surface fits up against this surface, it's nice, smooth, and flush. So the divots are going to be in there. You'll never remove the divots because those are recessed down below, but those aren't going to really impact you because the bearing surface or the main surface is this face, and as long as that's making more contact than your low spots, it's still going to sit on there nice and flat. So everything's on here nice and clean, and we're gonna take this chuck and we're gonna flip it up, and in the cams we go. Some of these chucks will have a spot like this one here is marked there 0 degrees, where it has a line up, and I don't. Actually, this one's pretty close. Okay, there is a mark right there. If you see a mark on here, it is nice to line that up because then the chuck is meant to go to that location, so the 0 and the V. But I promise you, I've taken a lot of these chucks off. Not all of them have that. So the big thing I worry about is trying to get it on there. If that has it, I'll use it. Otherwise, if it doesn't, I mount it. And the thing I look for is this. When I go back and I'm going to tighten the chuck on there, I want to make sure that registration line falls between V and V. If it starts locking down out here or well past the V, that's a problem, and then I need to reorient my chuck so that that registration line locks between the V and the V. Basically at, I don't know, your 4, 5, 5:30, somewhere in there is ideal. Some of them may go to 6 o'clock, but that's about the worst case scenario. So as I tighten this right now, you can see I snug it, and ooh, there's one right away. It goes almost to 6. But it's still between the V and the V. It's just right at that far point. So that's acceptable. This one here tightens down. All right, stops there about 5:30. This one stops there, I don't know, about 3:30, 4 o'clock. That one's going about 5:30. And there we go. All right, so all of them did, oh, one more. Did lock between the V and the V, which is what I'd expect. Now what I'm gonna do is just go around and tighten them one more time just to snug them up. So I just give it a little bit more, a little bit more, a little bit more. All right, so we've got our chuck mounted now. T-handle again, away from the chuck, back in the cart. All right, so now we're on to the 4-jaw chuck. So the 4-jaw, as I said, is independent. You have to go through and independently adjust each one of these jaws, but you can indicate your part, and as we were seeing run out on this indicator before, you can get your part perfect with a 4-jaw, but it takes some practice. And this will be a fun one to try to demonstrate, just because you won't be able to feel and touch and fully understand it. You're gonna have to do this when you get to the lab here, and it'll make a lot more sense. All right, so I think it's this T-handle that fits this. Nope. Must be this one. There we go. All right, so when I take this nut right here and I loosen this up, you can see just that one jaw is moving. If I take this one, loosen it up, just that one jaw is moving. So I need to go through and put my part in here now. If we're gonna follow the work instructions, which we're finally getting back to, we are at step 2. It says secure the part in a 4-jaw chuck so that 2 inches of the material extend from the chuck jaws. Indicate the part to within 5 thousandths total indicated runout, and that's what we're shooting for. So I'm gonna go here, my material's right there, and I need to open the jaws up enough that it's going to fit in the chuck. Not fitting. Okay, there, it finally accepted it. Now the next thing I do is, I know I'm close to size right here, is I look at this and I just kind of do this little trick where I will feel the jaws from side to side, because if the part is going to be centered, these jaws are going to be centered between there. And the way this works is, if I tighten this jaw here, it's going to tighten that jaw automatically, because it's taking the pressure of the part and putting it against that jaw. So realistically, when you get it all said and done, you're going to have 2 of these you're going to tighten, and it'll actually tighten all 4. But we're going to have to go back and adjust each one until we get it perfectly centered. So that's the game. So right now what I'm looking at is these 2 here are about even. My fingers are about the same depth on there. I feel pretty confident with that. When I go to these ones here, I can see that this one here is deeper up on top than what this one is. So I already know that that is off center. So I'm gonna go right off the bat and tighten this one a little bit and loosen this one a little bit, so that I know I'm closer to center. And by doing that, it'll make life a lot easier as we're going. So I'm tightening this one down, about that much, and loosen this one. Okay, so right now we can look at them and they're all approximately even. The other thing you can do is look at the face of it, and you can kind of compare where maybe the end of the jaw is versus these concentric rings that are on there, and just try to get yourself a visual so you're pretty close. So I can look at this corner, it's just slightly below that circle. Corner is just slightly below that circle. Corner is slightly below that circle. And slightly below the circle. So everything is good there right now, and it's very close to the size of my part, so I'm happy with that. That's where I'm gonna start. Now remember, in the work instructions at this point, it tells you need to have at least 2 inches sticking out. So I will come over here and just grab my steel rule and set 2 inches, and I'll be happy with that. And now I'm going to snug at least 2 of these jaws against the part and see where we are. Now chances are right now it's going to be off a ways. Actually, I'm gonna need that. I'm gonna just turn this on so you can get a visual of what it looks like. And that's 179 RPM. Okay, so we can look at it and we can see that that part is definitely off center right now.